So let's get started with the webinar. The agenda today is going to be Henrik Thomsen from ChemoMetec is going to be showing you a little bit about the NucleoCounter 3000. And then my name is Sean Burke from Novo Software. I'll be coming online at that point to show you how we can use the data acquired in the ChemoMetec NucleoCounter 3000 in FCS Express for image cytometry for cell-based assays. And just a little background between the two companies. ChemoMetec has been committed to work consistently to improve analytical measurements and techniques within the fields of automated cell analysis, particle counting, and liquid chemical composition determination. And they've become the supplier and partner of choice, not only for end users, but for distributors and agents. And Novo Software has been around for about 10 or 15 years now. We're one of the leading providers of flow cytometry software. In January, we announced a new version of FCS Express, FCS Express Image Cytometry. FCS Express Image Cytometry lets you interact between your images and your raw data in many different ways that you're going to see today. And we've also announced this collaboration between ChemoMetec and Novo Software so that we can directly import data from the NucleoCounter 3000 for advanced cellular assays. And we hope to be co-marketing these capabilities and to develop what we have done is developed FCS Express for image cytometry layouts for many of the ChemoMetec applications already, which you're going to see a little bit later. But with that all said, I'd like to hand the webinar over to Henrik now, and let me make you the presenter, and maybe you could introduce us a little more about the NucleoCounter 3000 and show us how it works.
Yes, thank you very much, and I now put on my screen for all of you to see, and I will start with just a very quick go through of the fundamentals of our instrument and the software, and I will do that with presenting a PowerPoint presentation, just a very short one, and afterwards I will go through some of our demo images showing you some of our assays and how to analyze the data on our system and how to export in ACES format that can be used in the Novo FCS Express for image. And the NC-3000 is the next generation cell analysis instrument, and the NucleoCounter NC-3000 here can do much of the same that a flow cytometry can do, but without the limitation of the flow. And we have this automated image cytometry that is based of 7 colors, light sources, and 9 filters, going full spectrum from UV to far red. And we have high-speed cell count, main application of the instrument for many users, but also a wide range of fixed protocols, a lot of apoptotic assays, annexin 5 caspases, and mitochondrial potential, and so on, along with GFP analysis and cell cycle. On top of that, we have open for the Flexi side, where you can analyze your own samples on your own fluorophores, creating protocols for the NC-3000. And the instrument is the big main difference from this instrument to flow cytometry is really the ease of use. It's very easy to operate, no training, calibration, or service is needed. And since we have no flow in this instrument, there is no rinsing, no clocking. Our data can be visualized by the plot manager or by exporting into FCS or ACS format, and in the ACS you can use FCS Express for image cytometry, and all this is to a relative low cost per sample. And if we go on to look at the first option, the fixed analytical assays or the fixed protocols, I told you we had the viability and cell count, which is our main assay, and which is the assay that most of our users depend on, And on top of that, they use all the fixed protocols and a lot of FlexiSite protocols. We have the cell vitality, which I will come back and demonstrate, and it is a measurement of cell health. And then on top of that, there is mitochondrial potential assay, annexin 5, caspase 3-7 or caspase 8 or caspase 9 assays, and DNA fragmentation assays. All these assays are for apoptosis measurement. And then the two-step and fixed cell cycle protocols, especially the two-step cell cycle, is a fast, robust cell cycle assay where you can get the cell cycle profiles of your cells in 5 to 10 minutes. And finally, there is a GFP transfection efficiency assay. On top of these fixed protocols, we have the user adaptable protocols, the FlexiSite, where you can use 3 channels, green, orange, and red channel for your own fluorophores, along with a counter stain, either Höchst or DAPI in the blue channel. And by that, you can have up to 3 channel assays looking for example CD markers, mito trackers, YFPs, RFPs, and a lot of other stuff. And as long as you conjugate to a photostable fluorochrome, you will be able to see your antibody. The technical details, just a short view through what our instrument really is. It is a camera on top, an optical tube going down the middle, and then emission filters. And this will collect the light from the sample tray, the emitted light from the fluorophores in the sample tray, that again is excited by our LED light sources in the bottom. And we use LED light sources to avoid lasers, because lasers need calibration, they drift, LEDs do not drift, and also lasers need a service, and changing LEDs have a very, very long lifetime, and it will probably outlive the instrument itself. For sampling our medias, we can go through with the cassette or the slides. The cassettes, wire 1 cassettes, consist of a plastic cassette that fits into a Eppendorf tube, for example, and you can drag up your cell suspension into the cassette. The staining solutions, DAPI and acridine orange, is inside the cassette, so your cells will be stained, and we will be able to measure acridine orange and DAPI on the cells. Acridine orange will stain all cells, DAPI will stain the dead cells, and so we can get a viability and total count. Very easy, and the cassettes are calibrated, so there is absolutely no user interference here, and therefore we get a very, very precise counting. On top of that, we have our NC slides for multi-samples. So there's 2 types of slides. There's the A2 and A8 slides, and here is an example of an A8 slide. And in these you can analyze multiple samples, both for counting but also all our analytical assays, the fixed analytical assays, apoptosis assays, and so on, and the FlexiSite assays. And the workflow of our instrument, just to simplify it a bit, is prepare the cell sample. It could be, for example, if you need to run a cell cycle, you could lyse your cells and stain them in DAPI, turn on the instrument, place the slide, in this case, in the instrument, choose the 2-step cell cycle, press run, wait a short time, and you will get your already done data out, and it will be, next thing you have to do is science. No big data fiddling around, it's pure science you have the time for. So no calibration, no compensation, no nothing, cleaning, whatever. It's just put in the sample, press the run button, and get your results out immediately. And now for the software itself. I have to close this one and open the software. Here you see an example of the software. The software is based around this image field. I will take the drawing here, have a pen so I can circle in the image field, where you will be able to see the image gathered. That is a big difference from flow cytometry to image cytometry, is that in image cytometry you take images, so you can see your cells afterwards. You can verify your data on the images. On top of that, we have our sample area out here, and we have our control area up here. So for the sample area, we can put in names of the different samples we are running. In this case, it's a count of aggregated cells assay in case you have very clumpy cells, and you can put in name on the different samples. It could be KEF cells, or it could be A3 Jurkat cells, or some other cells name, or a sample name from a barcode, or something like that. And then we could choose to run the sample. I'll just erase these drawings. So that is basic how the software works. Very easy. Choose your sample, your protocol here. It could be total count viability, it could be viability and cell count assay. And if you need to know how to do the assay, you can simply press the application note and get the application note with procedures and everything inside. And with pressing the run button, you will get an image corresponding to this one here. And if we go through some data, demonstration data, this is cell counting data, and you will be presented with a result like this. In this case, it's a viability and cell count Jurkat cells. And that's our sample ID in this case. You will also, for your own samples, have date and sample number and sample type in the sample image name up here. Then the operator is SRR in this case here. You have a viability percentage. You have a viability concentration, so you know that here it's 2.35 million viable cells per ml, and there is 207,000 non-viable cells per ml, and that gives a total cell count of 2.55 million cells per ml. On top, we have the estimated cell diameter based on the fluorescence area, and we have a standard deviation for that estimated cell diameter also. And finally, we have a clumpiness degree in percentage of cells in aggregates with more than 4 cells, meaning 5, 6, 7, and so on cells. All that you can do in cell counting. Use your cassette, as in this example, and you will have a very, very high precision cell counting immediately. If we go on to our analytical assays, I think we should start with the vitality assays, and I will show you the idea of the vitality assay by first selecting the vitality assay, mammalian cells, apoptosis, vitality assay is there, and the vitality assay can be run in A2 or A8 slides. The application note will tell you how to do, and there is one detail here in the application note where you can see actually what this assay does. We are measuring the reduced glutathione in the cells, and by measuring this part, we will know whether the cells have been oxidatively stressed, toxins, or starved, or anything. So we measure this as an equivalent to the cell health. On top of measuring this part with our Vitabrite 48, we use propylium iodide to measure dead cells. So we can measure the dead cells, the unhealthy, and the healthy cells. And if we go into our demo images on this one, we can try analyze here, show embedded image analyzing results, and it will fetch the results. It will give you, again, the name of the sample, the operator, the VB48 mean intensity for the living cell. That means the mean intensity for our dye that measures the glutathione level, and a standard deviation for this intensity, and again an estimated viability based on the propylium iodide. This is an untreated MR1 sample, and if we take our etoposide treated MR1 sample here, we get the same numbers, but a lot lower viability. We have here in our plot manager several possibilities. In the first plot, we see our acridine orange intensity versus area. We use acridine orange as a counter stain in this case here to be able to localize all cells. And for the cells, we then measure the VB48 intensity and the propylium iodide intensity. By double-clicking on a plot, we make it bigger, and here we can introduce polygons, quadrants as gates. I will choose to put in some polygons in this one, make it one up here in the upper area. That is a high propylium iodide intensity. Propylium iodide will go into permeable cells, and therefore it will stain the dead cells. So these cells up here in this gate will be the dead cells. On the x-axis, we have our Vitabrite 48 intensity. And that means the more Vitabrite 48 intense a cell is, the more Vitabrite 48 is bound to reduce glutathiones inside the cell. And that means, again, the more healthy the cell is. So by getting this population of healthy cells, we get a percentage of 82.8% of our total amount of cells being in this gate. Finally, we can gate the last area here, and this area here shows the Vitabrite 48 less intense cells, meaning the cells with low health. So now we have 11% dead cells, around 11%, around 5% of unhealthy cells, and around 88% of live healthy cells. If we then on this histogram here choose to gate and show only our live cell, that means excluding our dead cells, we can get a peak showing this population, the big peak, and the little peak showing this population out here. And by putting in a marker, we can get the percentage of live healthy cells out of all live cells. That means 94% of all live cells are healthy. If we then want to do the exact same on our treated sample, we can simply use row number 1 as a master row and then apply it. And by doing that, we get numbers on healthy and unhealthy live cells and dead cells. And we see the dead cell has increased to around 50%, unhealthy cells has increased to around 32%, and live healthy cells has decreased to around 17%. And if you look at our histogram here, you can see that 37% of our cells, we can move this marker, 37.6% of our cells are live and healthy, and of the live cells, the rest is unhealthy. So here we have a very quick measurement of healthy versus unhealthy cells. And it's mainly used for a quick apoptotic assays because the unhealthy cells tends to also be annexin 5 positive in most of the cases. And it's a 5-minute assay for measuring early apoptosis or cell health, and used also by production sites to follow their production of cells so that they can see if they are going into a rest or going into a low viability state. And by then measuring this, they can upfront, maybe 2 days in advance, see that the cells are going downhill and need some additives to the media. Please remember to say if you have any questions. So the next thing I want to go through is Annexin 5. And if we look at the Annexin 5, again, you can go into our protocol selector, apoptosis, Annexin 5 assay, choose the application node if you need to know how to do this. The protocol is listed here. And if you go into browse here, you can look into our untreated cells. We can reanalyze them. Have our data here presented as a Höchst. We use Höchst here as our counter stain. And then we have Annexin 5 FITS intensity versus propedium iodide intensity. Annexin 5 is the measurement of apoptotic cells. The more Annexin 5 bound to the cells, the more phosphatidylserine is dislocated to the outside of the membrane, meaning the apoptotic cells. And we have propedium iodide showing the dead cells here in the top upper part. And we have a histogram also showing the Annexin 5 intensity. And if we compare with our treated cells here, we here see a warning because the cell concentration was out of range. It's not really much out of range, but our instrument will warn you, because if you're out of range in cell concentration, there might be some staining kinetics that will not work, or statistics. If you are under range, the statistic might be bad. So this is a warning our instrument will give you. If we look into these two samples, it's very easy to see that in the lower row we have an increased number of Annexin 5 positive cells and Annexin 5 positive and PI positive cells, meaning we have a higher number of apoptotic and late apoptotic necrotic cells. To analyze this, we simply double click, and we can here put in a quadrant like this, and we can show that we have 42.7 what we would expect to be live healthy cells. We have 37.3% of the cells be live apoptotic or the apoptotic cells, and 19.6% of the cells would be late apoptotic necrotic cells. And again, if we want to have the same gating on the upper row, we can then this time put row number 2 as a master, and we can see it's drifted from 91% of live healthy cells to 43% of live healthy cells. And the Annexin 5 positive early apoptotic cells are drifted from around 2% to 37%. So the camptothecin treatment of these circuits had introduced very much apoptosis. And here it states that if we have any unsafe rows we want to save, we could do that, otherwise we could quit the plot manager. Finally, I think I will go into the cell cycle. The cell cycle, the two-step cell cycle protocol, is very, very fast and very easy. Going into mammalian cells, cell cycle, two-step cell cycle assay, and selected. Application node will tell that what we need to do is take our lysis buffer, mix it with our staining solution, DAPI, add it to our washed cells. If it's adherent cells, you can simply wash them with PBS directly in the tea flask or the 6 wells or whatever you have them growing in. If it's suspension cells, you spin them down, wash them with PBS. And after a 5-minute incubation, we will stabilize the sample, the solution, and we will then measure. So a 5-minute incubation is all that is really needed here. If we look into our cell cycle of untreated cells, we have here the easy results. Very nice cell cycle peak. We have a comparison of our cell cycle assay with a BD-LSR2, and we have shown that there is absolutely no difference between an LSR2 and the Image Cytometry NC-3000 NucleoCounter in regards of coefficients of variance on the G1 peak, which is normally the way you measure how precise a cell cycle is done. We can here create markers, for example, for the G1, for the S phase, and for the D2, like this. We can move the marker so that it becomes easier visible like this. And we can see 39% of our cells being in G1, G0, G1, 43 being in S phase, and 15% being in the G2 phase. And if we want to compare that with some cells treated, YAC1 cells treated with camptothecin, we can here see the difference very clearly, that in the second sample we have a sub G1 peak, we have something that looks like an arrest here in the S phase, and if we want to put the same markers on, it's simply just use the first one as a template for the second one. And we can see a lowering of cells in S phase and G2 phase, and that is because we have a hole in the S phase, so the cells going through S phase into G2 phase will be lowered, and that is what camptothecin does. All this is very nice and very easy if you have a few samples and you want to do a quick analysis of apoptosis or cell cycle, cell counting, and so on. But if you want to have a presentation tools like FCS Express for image is, or you want to do batch analysis, you will need to export these data. And we will always save the data in these samples here. So after running a sample, you can go into File and export the data very easily. Choose what format, FCS, ACS, excluding the image, or which I think we should do, use the ACS with the image, and here there is no image possible to export. We can take another one, jerk it untreated here. In the ACS format here, I can choose what to export, what to not export, and we can export the Hertz data, the area, the intensity, the maximum intensity per cell, and the same with the annexin 5 and propylium iodide. I can select or deselect, unselect all, select all, and then simply choose my place to save if I want to, and export it, and the file will be exported. It's already existing, I already exported it, but I can override it. And we will have an export of the ACAS file. And that file will bring us directly back to Sean that can import these files and show how to use them in FCS Express. So Sean, I think I will hand this presentation back to you. I can see there is some questions about how to upgrade our software. The software is really easy to upgrade. If you want to upgrade this software, you simply take our new software and then upgrade to this version by reinstallation. And the reinstallation will find out if you have the software already installed. If you have it already installed, then it will choose to upgrade. If you do not have it installed, it will our installation procedure will tell you how to install the software. You're very welcome to write an email to me or to ChemoMetec in general, and we will be very happy to support you in helping you to upgrade our software. So I will hand this back to Sean now.
All right, Henrik, thank you very much. And let me show my screen here. Very good. So if there's any questions about anything you've seen or that Henrik has talked about thus far, please make sure to type those questions in the questions and answers box there. I'm sure Henrik will be happy to answer those questions as we're going. Where Henrik left off was exporting the ACS files from the ChemoMetec device so that we can then open them in FCS Express. And what FCS Express is, it was built as a flow cytometry analysis, data, and reporting tool that's been in use for the last 10 or 15 years with research labs all over the world. And what we really excel at, besides having all the tools of regular flow cytometry software, is reporting the data, doing analysis on the data, and making this very easy, and easily creating many custom statistics and batch processing hundreds or thousands of samples, whatever size your experiments are, we can certainly handle that. So right now you see on the screen we have a welcome to the webinar screen here. But what I want you to notice is that we're actually in FCS Express right now. And if I come up to what we call our Applications button and insert a new layout, you'll notice that we have a blank page here. And the whole idea behind FCS Express is that it looks and acts just like Microsoft PowerPoint or Microsoft Word or the Microsoft Office suite of products. So if you've ever used Microsoft Word or Microsoft PowerPoint, which almost everybody has, you're going to be able to come into FCS Express and immediately be familiar with everything that we have to offer. So the way that the software works, let me take you through how we can insert plots and what a layout is, and then I'm going to show you more about some of the kind of custom or canned layouts or templates that we've put together with ChemoMetec for many of their standard assays. So you notice that we work up here off of the Microsoft Office ribbon format, and anything that's in the ribbon up here is going to be accessible for you to use. And just like Microsoft PowerPoint, what you would do is, if you're ready to create a PowerPoint presentation, is insert something, like a shape or a text box or a picture. But for FCS Express, we go way beyond this. We have the ability to insert many, many different types of plots. These are plots that are been familiar in the flow cytometry world for many years, and now they're available in the imaging world through companies like ChemoMetec and companies like ourselves that are trying to make these available to the imaging public. So if we wanted to start here, let's show you how we can create a layout and start working with your data very easily. The first thing that we would do is we'd insert a plot. In this case, let's choose a color dot plot. And just like Microsoft PowerPoint, we would draw a box on the screen. And unlike Microsoft PowerPoint, you're not going to be prompted to insert a picture or a slide. You're going to be asked to choose data. And you can notice here in our drop-down that one of our file formats is ACS, and again, that's the ChemoMetec output format that we can read directly into FCS Express. And let's just choose this Annexin-5 jerkit untreated sample. We'll click OK. We'll click Open. And what's going on now is that FCS Express is opening that file. We've inserted a two-dimensional plot for that file. Any of the parameters that you've stored with this file, if I click on the axis, they're all available here. So you notice when Henrik was acquiring data, he was acquiring the propydian iodine and Annexin-5 channels. Those are all here for us to choose if we'd like. And say if we wanted to insert another plot, and maybe we want to look at Annexin-5, and we wanted to look at propydian iodide, we would just put those on the axis here. And that's how we would choose these things. Now, one thing about any of these plots is that they're all completely customer formatable. So you can do anything to these plots that you would like. And the first thing I'd like to point out is that the scaling of these, it looks like this is on a linear scale, whereas when you've displayed these on the ChemoMetec device, it was probably a logarithmic scale. So if you right-click on any plot and choose Format, this is how we can come in and make any changes to the plot that you'd like to do. So I want to use this hyperlog scale that we have here. I just happen to know that this will work quite nicely. And if I click preview, you can see that now we're starting to look just like a regular Annexin-5 rubidium iodide assay that we're used to seeing. But again, like I said, if you want to make any changes to these plots, maybe we want to change the labels here, if we want to make the fonts a different size or a different color, and we'll do this. And you can see that our titles for the ticks have changed. Now this may seem very simple to be able to do these formatting changes, but what have you had to do in the past? To make these formatting changes in the past, what you've probably had to do is export these things to PowerPoint, put a little text box over something to white out the area, and then you're going to be off to publishing from that point. What we like to do in FCS Express is make anything that you see on the screen publication ready, and have that available for you to export in a variety of formats. If we come up here and we choose Save Layout, you'll notice that we can go out to PDF and we can go out to PowerPoint, or we could export as a picture, and these are all just one click away. And I'll show you, once we set up a little bit nicer of a template, how we can actually export these things very easily. So one thing that you're used to doing in the ChemoMetec software is setting up some gates, and how we do that. We have a gating tab up here. We have all these familiar type of gates. If we wanted to say create a polygon gate, and maybe just look at some of these hoosh cells here and click OK. Once we've done that, we've actually created a gate, and I'm going to insert what we call a gate view. And you can see that here's our gate 1. And what we can also do, what we call in flow cytometry as backgating, is display the cells that come from gate 1. These are the red cells here in gate 1. And we can show where they are in a different plot by displaying that color on the second plot. So by doing this, you're able to see which cells from one population in one plot fall within another plot. So this is very useful for tracking populations. But what we can also do, if you'd like to create quadrants, we can simply put a quadrant on here, right? And this is just like you're used to seeing in the ChemoMetec software. We have unlimited undo on our upper left corner. So if we undo a few times, we can actually remove our quadrants. And maybe what we want to do is create a few more gates. We'll call this the necro cells, and you'll notice that these will appear in blue. And if we create another gate, we can call this the apo cells. And we can change our gate colors if we want. We'll call these green, and you can see that these have appeared in green there. Now, one of the big powers of FCS Express is not just in the ability to do dot plots and scatter plots and these type of things. In FCS Express Image Cytometry, we have the ability to directly act between dot plots and images. So let me show you what I mean. In our Insert tab, we have a button for Picture Plot. And a picture plot isn't just a simple image. A picture plot is a dynamic, interactive image that's going to work between your data and the image itself. And what you're going to notice in this image, let me zoom in here a little bit, we'll right click and magnify axis, is that we have lots of different cells that were taken with this image from the ChemoMetec device, but they're all colored different colors, right? There's some red cells, there's some blue cells here, there's some green cells. And what this means is that any cell that's red falls in the red gate, any cell that's blue falls in the blue gate, and any cell that's green comes from the green gate. And let's just zoom in a little bit more so we can really see this. What this means is that as we move our gates, let's change our gate here, and you'll notice that on the plot below, cells are appearing green now. And that's because they're falling within that gate. So that means that we're actually starting to get spatial information based on our 2D plots that are interactive right down to the image. And another nice thing about this is that we can apply these gates directly to an image. So if we only want to find the cells that appear within this green gate, we can apply the green gate by dragging and dropping it as I just did, and see where these green cells fall. Now, we can take this a step further by inserting what we call a data grid. If you really want to get down to the single cell level, what I can do in this data grid is I can say, let's only view the cells for FTSE, propionium iodide, and let's view a PI intensity channel here. And what you'll notice is that we actually have little cutouts of all of the cells that appear in this assay. And we can scroll down this, and you'll notice that there's many, many, many thousands of cells here. And the nice thing is that we can actually apply gates directly to this. So if we only want to look at the cells that fall within this population, we can do that. We can get an idea of what those cells look like, and all of these things are going to be updating in real time for us. So as you've seen here, FCS Express offers the capability to move from dot plots to gate your data on multi-parametric data sources. We can show the original images. We can actually set gates on our dot plots and show them on the original images, and we can go down to the single cell level. And what I didn't mention yet is that we can also gate on the image itself. So if we only wanted to look at the cells that fall within this population, we'll just call this an image gate, and we'll make these cells orange. We can define this gate, and we see that the cells that fall within this gate are 0.48% of the total population, and I can apply this gate to another dot plot. And what you can see here is that it looks like most of the cells within this gate are down here. So again, what we did was we applied this gate, and we've noticed that most of the cells in this gate are live. So we're starting to get, again, spatial information from gating directly on an image, and again, we can do that directly onto our individual cells as well. And as we update these gates, you're going to notice that the statistics and these populations on the dot plots update in real time. So full interactivity between everything here. And let me delete this, and I'll delete this, and just to show you how quickly and easily we can export this type of data, let's remove our gate from this. If we want to export this whole thing to PowerPoint very quickly, we can just save this layout as a PowerPoint presentation. And let me put this on my desktop, and give me a moment here as this appeared on my next screen. And we'll open it after saving and click Save. And what's going on now on my other screen here is that PowerPoint is trying to open up, and we'll give it a minute here as I have a lot going on. And here's my layout in PowerPoint. So it looks exactly as it did in FCS Express. This is ready for publication now. We can send this out. All these images are super high resolution. We can make any of these any size we want. So if you're creating posters, it's very convenient to have these things at that size as well. But let's start looking at some more advanced layouts. We have some examples of the ChemoMetec Annexin-5 assay. We have some examples of cell cycle, which we can do specifically in FCS Express with modeling. And we also have an example of ChemoMetec's unique vitality assay, which we're very excited to support. So if we want to open up another layout, what we can do is let's come over here to our open layout, and let's open up our Annexin-5 assay template that ChemoMetec has been kind enough to help us at the Novo software create. Now, one thing you'll notice about this layout in FCS Express is that we have a nice image on top here. This is the ChemoMetec logo. If you have a logo for your lab, you can certainly insert this in here. You would just insert a picture, right? But then we also have some information on this plot, like the analysis date, the sample ID. We also have some statistics down here that we've created. And I want you to notice that these items are highlighted in gray. And they're highlighted in gray because they're what we call a token or a custom token. And these things are live updating statistics that are determined from the plot itself. So as you bring in new data, these sample IDs and the data analysis date will automatically change for you. You'll also notice that statistics here are considered tokens as well. And what this lets us do is these tokens, if I want to insert a text box, we can actually grab these tokens and drag them anywhere else in the software into a text box. And we can say the upper right quad % is, and then we have a text box describing what that quad percentage is. Now the really nice thing here is that these tokens update anywhere that they are within the software. So if we make changes to this, that token is going to update in real time, as you see here. And if we were to change the data in the batch process, which I'll show you in a few minutes, all these statistics are still going to update in real time for you. Another thing that we can do is to get more advanced with our tokens by using custom tokens here. You'll notice that we've created a few ratios here. One is a ratio of the necrotic to apoptotic cells. Another is an apoptotic to the live ratio. And what these ratios do, or what we've done here, is we've set up these custom tokens to act just like Microsoft Excel. We said we've put in an equal sign, and instead of a value, what we've done here is put in a token. We said, let's get the statistic for the number of events in the necrotic gate. And we've said, put in a division symbol here, and divide that by the statistic for the number of events in the early apoptotic gate. And when we do that, we can actually just drag this ratio token out here, and you'll notice that our ratio token is there, and this is the ratio of necrotic to live cells. And as our gates change, as any of these things change, let's move our necrotic gate, you'll notice now that our ratio is also changing in real time. So any tokens that are based upon other tokens are going to update in real time for you. This is going to act just like Microsoft Excel in that manner. So you can create these reports directly on your page with all these live updating statistics. You can get any statistics that you want. I also want to point out in the custom tokens here that we also have many functions. So there's a whole list of functions here that are equivalent to a graphing calculator. If there's any mathematics that you don't see on this insert functions list, you can let us know and we'd be happy to put that into the software for you. But it just goes to show you that we can do any sort of math that you would like. And in the end, when we're ready to save this layout quickly and easily, we can just save this as a PowerPoint presentation. And again, we'll call this test 2. And we'll open it after saving and click Save. And on my other screen here, we'll give PowerPoint a moment to open up. So hang on as it comes up here. Here's our layout. And you'll notice that we have our nice logo up top. We also have all of our plots. Everything looks exactly the same. And we have our statistics in here. So you can imagine how you can build up nice publication quality figures in here. You could have figure text and have that right below the image itself. And you'll never have to make any changes in PowerPoint or Photoshop to any of these things. You can do this all directly in the software. So another really nice assay or assay template that we've put together with ChemoMetec is this two-step cell cycle assay. As you saw Henrik describe that, the ChemoMetec device does a really great job at acquiring DNA analysis. One thing that FCS Express does a really nice job of is analyzing that data. So in our Insert tab, we have the option to insert a multi-cycle DNA plot. And what multi-cycle is, it's a DNA modeling piece of software that's located within FCS Express. And if I come over here to our multi-cycle tab, you'll notice that there's many models that we can choose from, there's many cycles that we can choose from. And this is what it looks like when we insert a multi-cycle plot. right? We have the DNA stain intensity on the x-axis, and we've modeled the different regions. You can see here that we have the G1, the S, and the G2 phase there. And let's erase those drawings real quickly. But the other thing we've done is inserted statistics for this plot very easily. And let me delete these so we can show you how we did this. Anytime you would like to get statistics either from a multi-cycle plot or for any type of plot, you can just right-click on it. And in this case, let's choose DNA cell cycle statistics. And here are all the statistics for the mean values, the percentage of cells that fall within G2, G1, and you notice that this value is 36, 37%. That's very close to what Henrik described earlier as well. And again, all these things can be formatted. So if I want to change, say, the color of my diploid G2 population, let's make that green instead, and let's make it a solid fill. You'll notice that when we do that, we've actually filled that part of the histogram. So again, we can start making these very, very nice publication quality figures by filling these histograms, and you'll notice, again, we've updated that. And the great thing about these is that they're all going to update in real time. If I were to move around my gate that defines the population, you'll see that my model is going to update, and all of my statistics are going to update in real time as we're making that change. So the last assay that I wanted to show you real quickly, or we'll go in a little bit more depth, is the vitality assay. This is something that ChemoMetec has done. I believe it's proprietary technology, which is very, very nice. What we can do with this vitality assay, you can see that we brought in the same types of plots that ChemoMetec has put together. We've put in some statistics for these things, and we've also done backgating. So you can see that with the acridine orange populations, where these different viable and non-viable populations fall. This is really nice. You can see that our non-viables are actually, gearing up towards the area on this side, maybe something you wouldn't be able to get out of some other data. But the real power of FCS Express, and one of the things that's going to bring to your assays, is the ability to do batch processing. So if I come up here to our batch tab, you notice that we have a whole bunch of actions here, like save to PowerPoint. So let's choose save the PowerPoint, and we'll say we'll open the presentations after saving. And what the batch process is going to do, it's going to look at all the different files that you have in what we call a data list. I'll show you this data list here. And right now there are no extra files added to this, but it's going to process all of those files together, and it's going to create a quick report for all of these things. And we can do many actions at the same time. If we wanted to save this as a high quality PDF, we could do that as well, and we'll call this PDF test on our desktop, and we'll put them all in one PDF file. So this is what's going to happen in the batch process. We're going to export the PowerPoint, and we're going to export the PDF. We could also go out to Excel with statistics if you'd like. But what we want to do first is add some new data to the data list. It just so happens out that Henrik gave me a bunch of vitality data that we can use here. So let's just enter in, I don't know, let's grab these samples here and add them to the data list, as you can see here. Now, if we want to change data on any files that we put into the data list, we just highlight the first data file, say change data on all plots, and you'll notice that we've changed data on all the plots to move to the next data file in the data list. So now that we have our data list full of samples, we can just click Run on the batch process, and we're going to do two things for each one of these batch processes. We're going to export to PowerPoint, and we're going to export to PDF at the same time. And we're just going to let this run. It may take a minute because we're actually loading up all of the image data. But one thing I wanted to show you while this is running is that on the Novo software website, all of the applications that you've seen today, we have example templates for these. So if you're running these files on the ChemoMetec device, you can actually come in here and grab the layouts that we used today. We also have many applications examples on the web page. These are all going to pop out and show you what the assay looks like. And you can actually come in here and you can download these for yourself. With FCS, we have a free 30-day trial. So you can download the trial, come in here and download the data, and actually start using all these application templates. And you'll notice here that in the background, while we were showing you this, that our PDF for the files opened up here automatically after the batch process was completed. You'll notice that our sample IDs are changing here, and we've actually created 8 different reports for the 8 different samples that we loaded into the batch process. On my PowerPoint screen here, I have my batch test, and let's see if I can bring this over. And you'll notice that we created 8 PowerPoint slides very quickly and very easily that are showing us all the data. So if you had 8 samples, or if you had 100 samples, or 1,000 samples, all you would have to do is load them up into our data list, set up your batch process, click run, and then your analysis is done. One other thing I want to draw your attention to is, since we're actually using these nice histograms here, I also want to show you that we can quickly and easily create overlays for these as well. You just select the files in your data list that you want to overlay, drag them and drop them onto the plot, add them as a new overlay, and you just click OK here. And what's going to happen is we're going to load in all of that data, and the new overlays are going to be created. So if I magnify my resolution, and let's format these overlays just so they look a little bit nicer, we'll smooth them up a little bit. And you'll notice that we've overlaid all the different samples from the data list that we chose here over the initial file. So creating overlays, if it's something you want to do and you have multiple data samples, there's a few ways we can display them as stacked or overlay them directly. A great way to view your data, a great way to visualize your data. And again, when you're ready to publish this or present it, you can do a simple save layout as, or the more efficient way is to come up and run your batch process on all of the samples and create a report for as many samples as you've created that day with your experiment. If you have this template and you have your own sample data for these, all you have to do is remove the data from the data list, and you'll notice that this template goes blank. If you want to refill it with data from a new day or a new experiment, all we have to do is choose that data, and let's choose something else, our untreated sample here, and that's okay. And what's going to happen here is that as this data loads, and we're going to load up the image, that all of these things are going to fill automatically, and that your sample is ready to run the batch process or export to PowerPoint or to PDF. So that just covers a lot of the basic features in FCS Express. Again, I want to draw you to our website where you can actually download some of these really nice templates. This is located on off of our main site. What you can do is come into our products web page, or you could download the free demo here if you'd like. It's under Image Cytometry, Example Applications. And once we come into the Example Applications tab, you can see that we have a whole ChemoMetec Example Applications page here that you can go to and access. So with FCS Express, what you are going to get is also great customer service. So if you have any questions regarding layouts or downloading the free demo or anything that you've seen today, you can contact us at info@denovosoftware.com. We also have our phone number in the United States and our website address up here if you'd like. We've also put in the contact information for ChemoMetec, their phone number in Denmark, and their website. So feel free to visit both of our websites to come in and get more information, to download a free demo of FCS Express so you can try your NucleoCounter 3000 data in there. And if you have any questions, right now would be the time to ask. Please type them in the questions and answers box if you have any questions about De Novo software or ChemoMetec. And Henrik, do you have anything to add to anything you've seen today?
No, I think it's very beautiful everything, and that both you and we can do this gating from image to plots and from plot to image, and you very good way of treating multiple data samples. So the batch processing is really fantastic, and also the way of doing the analysis of the cell cycles, getting the G1, G2, and so on coefficients, and seeing whether there is aneuploidity and stuff like that. This is really a great supplement to the NucleoView software that controls the NC-3000. So I really think that the Novo software and the ChemoMetec software can work very nice together on this, and we have very good cooperation. So I think this is covering very much everything.